4.1. In this chapter, we're going to be studying sequences and series. So our first example is right here. Right, the first four terms of the sequence whose nth term, or a general term, is given by these formulas. So the first thing to write down is an explicit formula, or the general formula. It's a formula that can find any term. So in our chapter, we'll often refer to this as like the nth term. So for example, in letter A, the first term you're going to write as A sub 1. Simply plug in 1, you get 7. The second term, plug in 2, you get 10. Plug in 3, you get 13. Plug in 4, you get 16. Now, the general formula, like this thing right here, can find any term. So if you wanted the 100th term, plug in 100 and you get 304. So that's why this particular formula is quite powerful. Let's try B. Plug in 1. This is a little bit more tricky. The top is going to be -1. The bottom is 2. So that's -1 over 2. Now for our second term, let's plug in 2. Notice if you plug in 2 right here, -1 squared, that's +1. So that's 1 over 3 squared is 9, minus 1 is going to be 8. Let's plug in 3. Now it's going to be -1, because -1 cubed is negative. Plug in 3, that's 27 minus 1 is 26. And then 4, -1 to the fourth is 1. And then 3 to the fourth is 81, that's over 80. So we could keep going, but the question just says first 4, so there's our first 4. For this particular problem, you want to note that this thing in particular is useful, because what that's going to do is it makes the signs alternate. So if you ever have a question where you have to make that happen, this is what you want to think about. -1 to some power, because notice how the first one's negative, positive, negative, positive. So very helpful there. Now our next formula is going to be recursion. It says find the first 4 terms in the sequence in which a1 is 5, an is this thing, for n is greater than or equal to 2. So recursion, or the recursive formula, is a little bit different. The idea here is it'll use the previous term to find the next term. So for example, a1 is 5, you write that down. What this thing means is the previous term. Previous, that's what a sub n minus 1 means. And a sub n is like, think of it as your current term. So to find the current term, you have to just do 3 times the previous term, add 2. So for example, if I want the second term, I got to take the previous term, 5, do 3 times the previous, and add 2, which is going to be 17. If I want the third term, I have to do 3 times the previous, which is 17 now, and add 2, which would be 53. If I want the fourth term, I do 3 times the previous, which is 53, add 2, which is 161. So here are my 4 terms. Now you also notice that this thing right here seemingly doesn't do anything. It's actually important for the definition, because that means start the formula at the second term. And we'll talk more deeply about these details, but for now, just think of it as this thing is important. Okay, let's try one more here. First 4 terms. So the first term is 3. Notice how it says 2 times the previous term plus 5. So that's going to be 11. 2 times the previous term plus 5. That's 22 plus 5, which is 27. And now the last one, 2 times the previous term plus 5. That would be 54 plus 5, which is 59. Now for the final part, just find the general formula or explicit formula for this given sequence. So now it's saying, there's my first term, second, third, fourth, fifth. Make a formula. So for now, you're going to practice your intuition. I want you to notice that it's going up by 5 every time, which means there has to be like a 5n in here, because that's the only way you're going to add 5 every time. But notice how if you plug in 1, you get 2. So think about it. If I plug in 1, I currently get 5. So to fix that, I'm going to put minus 3. So now I can check it. Plug in 1, I do get 2. If I plug in 2, I do get 7. So it's definitely checking out. So there's my formula. And for now, again, we're using intuition. Later on, I'll teach you how to do it more systematically. Now for this one, letter B, notice how you're going times 2 every time, which means I'm going to need 2 to some power. So I'll put like 2 to the n. Now what's really tricky is there's a 3 here, so it's 3 times 2 every time. So I'm going to have to do 3 times 2 to the n. And let's see if that works. A1, that's going to be 6. A2 is going to be 12. A3 is going to be 24. So it's pretty close. 6, 12, 24. I have these numbers. I just don't have this 3. So think of it as like the series is just one step ahead. So to adjust this, I'm just going to do a -1 right here. Because if I do that, let's see what happens. If I plug in 1, I get 3 times 2 to the 0, which is 3. Good. 3 times 2 to the 1, which is 6. 3 times 2 squared, which is 12. So it checks out. So here is our formula. And finally, recursion. So this is going to be a little bit easier. For recursion, you just need to write this down. You need 3 pieces. Step 1 is you define the first term. Step 2, write the formula. So for example, this one I can see add 5 every time. So take the previous term, add 5. And step 3, you state where it begins. So 4, I want this to begin at the second term. So n is greater than or equal to 2. So 2 is often very common because you typically start on the second term once you define the first term. So there's your answer. So let's try it again. Define the first term. Write the formula. So I need the previous term and multiply it by 2. And start it at your second term. And we're done.